Hi guys, welcome to another quick revision video. Today we're looking at the radian measure, also known as the circular measure. In this problem, we are told that a bicycle wheel of diameter 60 centimeters covered a distance of 250 centimeters in 3 seconds. How many radians per second did it turn? I added a wheel here. Imagine this is a straight line underneath that this wheel goes over. If this is the starting point, let's say the wheel turned all the way down to that point, and let's say that is the distance we're talking about here, 250 centimeters. Okay, so now we are talking about a wheel here. Definitely that tells us that we're talking about a circle. Okay, and then this circle covered a distance. So that distance is basically the length of an arc on that circle. The 250 centimeters is this distance, which we'll consider to be an arc length, right? So now we have been asked how many radians per second did it turn? But what is radians? Well, radians is a measure of an angle. Okay, and by definition, 2 pi radians is the same as the conventional 360 degrees. So that's one full turn around a circle. Okay, now, but where does this radian come from? Well, basically, the definition of a radian is that is the angle that is subtended by a radius that is equal to the arc length. So this is what 1 radian is, okay? So 1 radian is equal to basically the length covered divided by the radius, okay? Which in this case is equal, therefore we have 1. So that's the definition for 1 radian, okay? But now we said 2 pi radians equals 360. So why is that? We're going to relate in the same way the angle and the arc length. If we go full circle, that would be equal to the perimeter of a circle, which is 2 pi r. So that would be 2 pi r divided by r, as we did earlier. So that should be equal to 360. So if the r's cancel out, therefore we have the definition for this angle radian, theta radian, is now going to be equal to 2 pi equals 360. Okay, so this is a full circle. So a full circle is 2 pi radians. Okay, so just clarifying what we said there. How about a semicircle? Well, a semicircle will definitely be half of a circle. So if we divide both sides by 2, therefore we have pi radians. It's often just written as rad is equals to 180. 2 to itself into 360, 180 times. Okay, so this is the idea of a radian. Okay, it is the angle subtended by an arc length and a radius. Okay, now let's move back to our problem, because we now have a formula that relates the information that we have been given. Okay, so the angle that this wheel turns would be equal to, so the angle theta, let's say angle theta turned by wheel is equal to theta. Yeah, so theta is the angle turned by the wheel. So this theta will be equal to the length of the arc cover divided by the radius, which will be equal to, we know our arc length we already said was 250. The arc length we already said was 250 centimeters divided by the radius, which is 30 centimeters. Remember, the diameter given is 60, so 60 divided by 2, we have 30. So now the zeros cancel. Our angle theta is equal to 25/3. But remember, the question says the angle per second. So angle turned per second is equal to the angle divided by 3, because 3 seconds, right? So the angle is 25/3. If we're dividing that by 3, if we change this to multiplication, we just switch these values. We have 25/3 multiplied by 1/3, which gives us 25/9, because 3 times 3, 9. And now, how much does 9 goes into itself? 1 times into 25. 9 times 2 is 18, so it goes there 2 times. 25 minus 18, that's 7. 7, 9 doesn't go there, so we add a 0, so we add our point. So 9 goes into 70. 9 times 7 is 63, so that's 7 times. But 70 minus 63, that's 7. 9 doesn't go into 7, so we add another 0. 9 goes into 70 again, 7 times. So of course, this is going to repeat. So therefore, our angle in seconds is equal to 2.78 radians. Okay. Now, I hope this gives you a good introduction to the topic of radians. Follow me for more.